Hello, boys. 2.3. Solving linear equations in one variable. So, lesson 2.1 was just using algebra on equations that just used addition and subtraction. Lesson 2.2 was just about multiplication and division. And now in 2.3, we're going to see how we can solve for variables when they have multiplication and addition and division used in the same problem. Funny story, I just had my buttons so I can pause and play the recording. I had it at Control P, but when I did that, it wanted to print, so I had to change it. Anyway, moving on. Guess what, boys? During that pause, you're probably just like, oh, Bryce had a normal pause. Wrong. I cut my fingernails. So, there's a lesson to be learned there, but I don't know what it is, so we'll keep going. Alright, so in this equation, we have 2 times x plus 3 equals 5. In this scenario, we have both multiplication and addition being applied to our variable. So the question is, what order do we do our operations in for this algebra? What was that? You said it kind of sounds like order of operations? Yes. And no. So let's review order of operations, because it works a little bit differently, but I'll show you. So PIMDAS. And remember multiplication and division, and ugly bracket. There we go. These things happen in the same step. These things happen in the same step. PIMDAS. So in regular order of operations, we work our way from top to bottom. Parentheses first, exponents, multiplication and division, addition and subtraction. But in algebra, what are we trying to do? We're trying to get the variable by itself. And remember our thought process? We say, so let's just look right here. What's happening to x? It's being multiplied by 2. How do we undo multiplication by 2? We divide by 2. So in this case, I'm undoing the multiplication. So for algebra, we're undoing multiplication, we're undoing addition, and so whenever we're doing our steps, we're actually going to go and reverse PIMDAS. So we're going to start with addition and subtraction, then we're going to go to multiplication and division, and then we're going to go exponents and parentheses. I don't really know a scenario where that would work, but I don't know. We'll deal with parentheses when we see it again. Parentheses might start. Anyway, forget about parentheses. The point is, we'll start with addition and subtraction, go to multiplication and division. Yeah, so let's look at this case. What's happening to x? Two things, being multiplied by 2 and added by 3. So what do we need to do first? Well, according to reverse PIMDAS, because we're undoing everything, because we're trying to get the x by itself, we're going to do the addition and subtraction first. So it's being added by 3. How do we undo addition by 3? We subtract by 3. What we do to one side, we got to do to the other. What are we left with on the left? Well, these cancel. We're left with 2x. What are we left with on the right? 5 minus 3 is 2. 2x equals 2. What's happening to x? It's being multiplied by 2. How do we undo multiplication by 2? We divide by 2. What we do to one side, we do to the other. Cancel, cancel. We're left with x. Cancel, cancel. What are we left with? 1, right? Because this 2 becomes 1, this 2 becomes 1, and 1 divided by 1 is 1. Don't get confused by this. These don't cancel and become 0. They cancel and become 1, because what's happening here? 2 divided by 2. 2 divided by 2 is 1. You know this. And if you look at the bottom of page 54, it also gives you a good step-by-step guide. I'll go ahead and read it to you. Step 1, simplify both sides of the equation. So simplify, say we had, this was like 5 plus 2 over here. First step we would do is add them together and get 7. And in these cases, we would, during the simplifying step, we would actually use PIMDAS. We'll show an example of that when we get to it. But there was nothing we could do in this problem is the point. Then we want to isolate the variable term. So the term, remember, it's the parts in between addition and subtractions. So this is a term, but it's a variable and a coefficient. So that's what we did. We got the term by itself, and then we got the variable by itself. So simplify, isolate the term, isolate the variable. Yeah, so you can just keep that in mind. That's basically the step we're doing. Just isolate. The way we do that is by working backwards through PEMDAS. Let's take a look at the next example they have, page 55, example 2.3b. Okay, we got 8x plus 3 equals 5x plus 9. Now, like I said before, first thing we want to do is simplify. Can we simplify anything on the left? No. Can we simplify anything on the right? No. And now I'm going to add a step here because this problem has it. We're going to combine like terms. So what does it mean to be a like term? It means it has the same variable and the same variable or variables and the same exponents on those variables. So let's take a look. Do we have any terms in common? Let's use our squares and triangles. Yes, we have x terms. So we have one right here and one right here. And we have our non-x terms. So what we want to do is we want to get all these to be together. So we'll start by moving the 3. So how do we get the 3 to combine with the 9? Well, we got to move it from this side of the equal sign to this side of the equal sign. How do we do that? We can subtract the 3, and what we do to one side we got to do to the other. And remember, we're starting with addition and subtraction because we're doing reverse PEMDAS. These cancel. What are we left with on the left? 8x equals 5x. What's 9 minus 3? 6. Okay. So now we still need to combine our x terms. So let's combine. We can move the 8x over here, but we want to get the x terms by itself. So since there's already a non-x term over here, we'll move the x to the other side. So how do we move the 5x from here to here? Well, we can subtract it on this side, minus 5x, and what we do to one side, we got to do to the other. These cancel. What are we left with on the right? 6. And what are we left with on the left? 8x's minus 5x's gives us 3x's. And now we see 3x equals 6. What's happening to x? It's being multiplied by 3. How do we undo multiplication by 3? We divide by 3. What we do to one side, we do to the other. Cancel, we're left with x. 6 divided by 3 is 2. Great. Okay. Example 2.3c. 2 times x plus 3 minus 8 equals 6 times x minus 7. Now this is a case where we need to simplify first. So when we're doing the simplify, we just do regular PEMDAS. So parentheses, can we do anything inside the parentheses? No, we can't combine an x and a 3, and we can't combine an x minus 7. Next is exponents, no exponents. Multiplication, division, yes. Distribution is a form of multiplication. So we will distribute this 2 through, and we will distribute this 6 through. So starting with the 2, 2 times x is 2x, 2 times 3 is 6, and then we didn't touch our 8. And then we've got 6 times x is 6x, 6 times negative 7 gives us negative 42. Okay, and now can we do any more simplifying? Yes. On the left we have our 6 minus 8, so 2x, 6 minus 8 is negative 2, equals 6x minus 42. And now we have a similar situation as the one we had in the previous problem. So we need to combine like terms. So let's use squares to represent our x's, circles to represent our non-x's. We want to get all the circles together, and we want to get all the squares together. So how do you know which direction to go? I mean, we can move negative 2 this way, or we can move negative 42 this way. Well, I usually like to keep the variable positive. So whichever side is gonna, if we move 6x over here, we're gonna have to subtract 6x. So if we subtract 6x on both sides, this is gonna give us negative 4x over here, which I'd rather not have it negative. So we're gonna move 2x over here, and we'll see what that does. To move it, we'll have to subtract it. Minus 2x, what we do to one side, we do to the other. Okay, these things cancel. What are we left with on the left? Negative 2 equals 6x minus 2x gives us 4x's minus 42. And now we're just stuck with a basic problem that we started this lesson with. What's happening to x? It's being multiplied by 4 and subtracted by 42. We're doing reverse PEMDAS, so we're going to deal with the subtraction and addition first. So how do we undo subtraction by 42? We add 42. What we do to one side, we do to the other. These things cancel. We're left with 4x over here. Negative 2 plus 42 gives us 40. And then you can see the answer. What's happening to x is being multiplied by 4. We undo that with division by 4. What we do to one side, we do to the other. We're left with x, and then 40 divided by 4 gives us 10. X equals 10. And if we were to plug in 10 right here, we would get 10 plus 3 is 13, times 2 is 26, minus 8 is 18. If we were to go over here, 10 minus 7 is 3, times 6 is 18. So they both would equal 18. So we know we did it right. So far, all the problems we worked with ended up with our variable equaling something specific. So these next two examples are going to be a little different, and we'll see why. So we want the goal of getting x by itself, just like normal. In this case, we can simplify first because we can do some distribution here. 2 times x is 2x. 2 times 3 is 6. Equals 2x plus 6. Let's get all the x's to one side. So let's move this 2x to the other side. How do we do that? We'll subtract by 2x minus 2x, and what we do to one side we'll do to the other. These things cancel, we're left with 6. These things cancel, we're left with 6. Whoa! We got 6 equals to 6. And no more variables. Our variables are gone. And if you wanted to do one more step, you could subtract 6 from this side. What you do to one side, you do to the other. Cancel, cancel. We're left with 0 equals 0. Whoa, what the heck is going on? Okay, so let's take a look at this step right here. 2x plus 6 equals 2x plus 6. Are those two things equal? Yes, they're exactly equal. What does that mean? That means that no matter what we plug in for x, it's always going to equal the other side. If we plug in 1, it'll be 1 over here. 2 times 1 is 2 plus 6 is 8. Same thing over here. If we plug in 1,000,000, it's going to be 2,000,006 equal to 2,000,006. So it doesn't matter what value we choose for x, this is always going to be true. Let's take a look back at one of the previous problems. If we plugged in something other than 10, we're not going to get an equal statement. Let's look. If this is 1, 1 plus 3 is 4, times 2 is 8, 8 minus 8 is 0. Then over here, 1 minus 7 is negative 6. Negative 6 times 6 is negative 36. 0 is not equal to negative 36. So 10 is the only value that will work in this equation. But over here, it doesn't matter what value our x is. It's always going to be equal. So we can plug in whatever we want. So whenever we end up with a number being exactly equal to itself, we can consider that a true statement because 6 is equal to 6. Yes, that's true. And 6 is always equal to 6 is how you can kind of think of it. 0 is always equal to 0, meaning it doesn't matter what our x value is. And let's take a look at one more example on the right. So kind of similar. We'll see how they're different in a second. We can, once again, our goal is trying to get x by itself, and we can simplify first. Let's distribute that 2 through. 2 times x is 2x. 2 times 3 is 6 equals 2x plus 5. Let's go ahead and get our x's together. So we'll subtract 2x on this side. What we do to one side, we'll do to the other. Cancel, cancel. We're left with 6 equal to 5. We're in the exact same situation, and just for the sake of getting it more simplified, let's subtract 5 on this side. What we do to one side, we'll do to the other. That leaves us with 0 equal to 1. Now, this is false. 0 is not equal to 1. 0 is never equal to 1. So in this case, just like in this case, 0 is always equal to 0, meaning it doesn't matter what you put for x, it's always going to be true. This means 0 is never equal to 1. It's a false statement. It doesn't matter what you choose for x. This is always going to be, we're not going to be able to make these two things equal. And you can try it yourself. If you plug in 1 and 1, we got 2 plus 6 equals 8. And then 2 plus 5 equals 7. If we do 2 and 2, 2 times 2 is 4, plus 6 is 10, 2 times 2 is 4, plus 5 is 9. This one is always going to be 1 more than this one, and there's nothing we can do about it. There's a way for me to show why that works pretty easily using graphs, but if you don't know what graphs is, that's fine. If you do know what graphs is, think about the slope. We can see our slope on the coefficient of our variable. You know that if they have the same slope, they're going to be parallel lines, and they would never intersect. But if you don't know that, don't worry about it. Just know that if we get a false statement at the end, we can't find any solution for x. If we get a true statement like this, every solution, every value of x is a solution. Okay, that's it for that lesson. Write down your questions. Let me know if you have any. And I will make the homework for this lesson too. Okay, bye.